surds, and square roots. If we have a square with each side 1 meter, what is the length of the diagonal? Well, we can work that out using Pythagoras' theorem. We have a right angle triangle, so x squared equals 1 squared plus 1 squared. So x squared is equal to 2, or taking the square root of both sides, x is equal to the square root of 2. It turns out that the square root of 2 cannot be written exactly as a fraction or as a decimal. As a fraction, the square root of 2 can be written approximately as 17 over 12. A better approximation is 577 over 408, and we can improve it again as 665,857 over 470,832. And we can go on getting better and better approximations. These will get progressively better, but none are perfect. As a decimal, we can write the square root of 2 as 1.14, or 1.1414, or 1.1414213563, but it's a non-recurring list of numbers that does not end, ever. So, as an answer to the top question, we could give any of these fractional values of square root of 2, or write the square root of 2 to a certain number of decimal places. But however we did it, it would only be approximate, and may or may not be accurate enough for the requirements that we need. If we just leave the answer as x equals the square root of 2, this is exact, although we do not know the value of the number. However, the value could be worked out at a later stage to whatever accuracy is needed. Simplifying roots. If we get an answer to a problem and leave the expression involving square roots, it can quite often be simplified. We have the following rules. First one, a times the square root of n plus b times the square root of n is equal to a plus b times the square root of n. Also, the square root of m times n is equal to the square root of m times the square root of n. And similarly with division, the square root of m divided by n is equal to the square root of m divided by the square root of n. And also, the square root of n squared is just equal to n. Now, when simplifying an expression involving surds, we try to have as few surds as possible left in our answer. We also try to have the smallest number possible inside the surd. If we have a fraction involving surds, we try not to have a surd in the denominator, the bottom part of the fraction. So let's have a look at some examples. If we want to simplify the square root of 12, we notice the square root of 12 can be written as the square root of 4 times 3, which is the square root of 4 times the square root of 3, and the square root of 4 is 2. So we're left with 2 root 3. In this case, the number in the root is as small as possible. Suppose we want to simplify the square root of 5 times the square root of 15. The square root of 5 times the square root of 15 is the square root of 5 times 15, which is the square root of 75. Now the square root of 75 can be written as the square root of 25 times 3, which is the square root of 25 times the square root of 3, which is 5 times the square root of 3, or 5 root 3. An alternative way of doing that is to say the square root of 5 times the square root of 15 is equal to the square root of 5 times the square root of 5 times 3, which is the square root of 5 times the square root of 5 times the square root of 3. Now the square root of 5 times the square root of 5 is 5, so our answer is 5 times root 3, or just 5 root 3. In question 3, we're asked to simplify the square root of 12 plus the square root of 5 times the square root of 15. Now, we have worked out that the square root of 12 is 2 root 3. And we've also shown that 5 times the square root of 15 can be written as 5 root 3. So if we have 2 root 3 plus 5 root 3, this gives us 7 root 3. In question 4, we were asked to simplify the square root of 8 over the square root of 2. Well, the square root of 8 over the square root of 2 can be written as the square root of 8 over 2, which is the square root of 4, or 2, which is much simpler. Now, one useful thing to do is what's called rationalizing the denominator. If you consider the fraction 1 over the square root of 2, we can multiply it top and bottom by anything we like, so we'll multiply it top and bottom by the square root of 2. So we have 1 over the square root of 2 times the square root of 2 over the square root of 2, which gives on the top the square root of 2, and on the bottom 2. So 1 over the square root of 2 can be written as the square root of 2 over 2. The second expression is regarded as being simpler than the first. Now, on a calculator, evaluating either is exactly the same. But those of us, including me, who can remember a pre-calculator era, found evaluating the second division far easier. If you try to work out 1 over the square root of 2, you have 1.000 to however many noughts you want, divided by 1.4142136. which is an extremely long division sum. On the other hand, the square root of 2 over 2 can be written as 1.4142136 divided by 2, which is a very simple short division sum. So we try to never leave a surd in the denominator. So let's have a look at some examples. Example 1, 5 over root 10. Now, if we start with 5 over root 10, we can multiply top and bottom by root 10, which gives us 5 root 10 over 10. Now, the 5 and the 10 cancel to give us root 10 over 2. In the second example, we have 1 over 2 plus root 3. Now, if we multiply the top and bottom by 2 minus root 3, we can use the property of the difference of two squares. So on the top we have 1 times 2 minus root 3, which gives us 2 minus root 3. And on the bottom we have 2 plus root 3 times 2 minus root 3. Now, because of the difference of squares, that can be written as 2 squared minus root 3 squared, which gives us on the top 2 minus root 3, but on the bottom 4 minus 3, which is 1, and so our answer is 2 minus root 3. In question 3, we've got a similar one, 2 plus root 2 on the top and 2 minus root 2 on the bottom. Now, if it's 2 minus root 2 on the bottom, we multiply top and bottom by 2 plus root 2. So on the top we have 2 plus root 2 times 2 plus root 2, and on the bottom we have 2 minus root 2 times 2 plus root 2. Now the top expands as 2 squared plus 4 root 2 plus root 2 squared. It's the first term squared plus twice the product plus the second term squared. And on the bottom we have 2 squared minus root 2 squared. So on the top it's 4 plus 4 root 2 plus 2, and on the bottom it's 4 minus 2. So this gives us 6 plus 4 root 2 all over 2, or 3 plus 2 root 2. Now, the following is an exercise. You can pause the video at this point and have a go at them yourself. Once you've tried them, you can restart the video and I'll go through the answers. Well, in question 1a, we're asked to simplify the square root of 12. Well, the square root of 12 is the square root of 3 times 4, which is the square root of 4 times the square root of 3, which is 2 times root 3, or 2 root 3. In question B, we're asked to find the square root of 18. Well, 18 can be written as 9 times 2, and the square root of 9 times 2 can be written as the square root of 9 times the square root of 2, which is 3 times root 2, or 3 root 2. In question C, we're asked to simplify the square root of 72. Well, 72 can be written as 36 times 2, so if we take the square root of that, that can be written as the square root of 36 times the square root of 2, which is 6 root 2. In question D, we've got the square root of 8 plus the square root of 50. Well, the square root of 8 can be written as the square root of 4 times 2, and root 50 can be written as root 25 times 2. So this is root 4 times root 2 plus root 25 times root 2, which is 2 root 2 plus 5 root 2, or 7 root 2. In question E, we have root 27 minus root 12, which can be written as root 9 times 3 minus root 4 times 3. Which is root 9 times root 3 minus root 4 times root 3, which is 3 root 3 minus 2 root 3, which is just root 3. In question F, we're asked to simplify 4 root 45. Well, that's 4 times root 9 times 5, which is equal to 4 times the square root of 9 times the square root of 5. Now the square root of 9 is 3, so it's 4 times 3 times root 5, or 12 root 5. In G, we have 3 root 8 plus 4 root 2. Now root 8 can be written as root 4 times 2, so this is equal to 3 times root 4 times 2 plus 4 root 2. Well, that can be written as 3 times root 4 times root 2 plus 4 root 2, which is 3 times 2 times root 2 plus 4 root 2, or 6 root 2 plus 4 root 2, which is 10 root 2. In question H, we have root 2 times root 18 plus 3 times root 8. If we expand the brackets, that's 2 times root 18 plus 3 times root 8, which can be written as 2 times root 2 times 18 plus 3 times root 2 times 8, which is equal to 2 times root 36 plus 3 times root 16, or 2 times 6 plus 3 times 4, which is 12 plus 12, or 24. Now in question 2a, we have to expand the brackets 3 plus root 2 times 3 minus root 2. Now we can do this. The first pair is 3 times 3. The outer pair is 3 times minus root 2, or minus 3 root 2. The inner pair is plus 3 root 2, and the last pair is minus root 2 times root 2. Well, that simplifies. You have 9. The 3 root 2's cancel out, and you're left with 9 minus 2, which is 7. In question B, we have 1 plus root 3 all squared. Now that's the first term squared, plus twice the product, plus the last term squared. So it's 1 squared, plus 2 times 1 times root 3, plus root 3 squared, which is 1 plus 2 root 3 plus 3, or 4 plus 2 root 3. In question C, we have the square root of 20 minus 7 times 3 minus root 5. Well, that's root 20 times 3 minus root 20 times root 5 minus 7 times 3 plus 7 root 5, which is 3 times the square root of 4 times 5 minus the square root of 20 times 5 minus 21 plus 7 root 5. Well, that's 3 root 4 times root 5 minus root 100 minus 21 plus 7 root 5, which is 3 times 2 times root 5 minus 10 minus 21 plus 7 root 5, which is 6 root 5 minus 31 plus 7 root 5, which is 13 root 5 minus 31. In question D, we have 5 minus root 63 times root 7 minus 2. If we expand the brackets, the first pair is 5 root 7, the outer pair is minus 10, the inner pair is minus root 63 times root 7, plus, and the last pair is 2 root 63. Now, this gives us 5 root 7 minus 10 minus the square root of 3 times 3 times 7 times root 7 plus 2 root 9 times root 7, which is 5 root 7 minus 10 minus the square root of 3 times 3 times 7 times 7 plus 2 root 9 times root 7, which is 5 root 7 minus 10 minus 3 times 7 plus 2 times 3 times root 7, which is 5 root 7 minus 10 minus 21 plus 6 root 7, that's 11 root 7 minus 31. In question E, we have the square root of 3 minus the square root of 2 all squared. Well, that's root 3 squared minus twice the product, that's minus 2 root 3 root 2 plus root 2 squared. So that's 3 minus 2 times root 3 times 2 plus, and the square root of 2 all squared is 2. So that gives us 5 minus 2 root 6. In question F, we have root 5 minus 4 times root 5 plus 3. So the first pair is root 5 times root 5, then root 5 times plus 3, then minus 4 times root 5, and minus 4 times 3, which gives us 5 plus 3 root 5 minus 4 root 5 minus 12, which is minus 7 minus root 5. In question 8, we have root 5 plus root 3 squared, which is root 5 squared minus twice the product, 2 root 5 times root 3, plus root 3 squared, which is 5 plus 2 times root 5 times 3, plus 3, which is 8 plus 2 root 15. In question G, we have root 8 minus root 3 times root 2 minus root 3, which gives root 8 times root 2 minus root 8 times root 3 minus root 3 times root 2 plus root 3 times root 3. Now this gives us root 16 minus root 4 times 2 times root 3 minus root 6 plus 3, which is 4 minus root 4 times root 2 times root 3 minus root 6 plus 3. Now the 4 and 3 add to make 7, so we have 7 minus 2 root 6 minus root 6. And so that's 7 minus 3 root 6. Now in question 3, we're given some fractions, so we want to rationalise the denominator. Now we've got 4 over root 8. Root 8 can be written as root 4 times 2, which can be written as 2 root 2. So we have the original is equal to 4 over 2 root 2, or 2 over root 2. Now if we multiply top and bottom by the square root of 2, we'll have 2 root 2 over root 2 times root 2, which is 2 root 2 over 2. Now the 2's cancel and the answer is root 2. In question B, we have 1 over the square root of 3. Now if we multiply top and bottom by the square root of 3, that will give us root 3 on the top and 3 on the bottom. So our answer is root 3 over 3. In question C, we have root 50 over root 2. If we multiply top and bottom by root 2, that gives us root 50 times 2 on the top, which is root 100, and the bottom root 2 times root 2 is equal to 2. Now the square root of 100 is just 10, and so 10 over 2 is equal to 5. So our answer is 5. In question D, we have the square root of 50 over the square root of 18. Again, if we multiply top and bottom by the square root of 2, that will give us the square root of 50 times the square root of 2 over the square root of 18 times the square root of 2, which is square root of 50 times 2 over the square root of 18 times 2, which is the square root of 100 over the square root of 36, which is 10 over 6, or 1 2/3. In question E, we have 3 over root 18. If we multiply top and bottom by root 2, we'll have 3 times root 2 over root 18 times root 2, which is 3 root 2 over root 36, which is 3 root 2 over 6. The 3 and the 6 cancel to give root 2 over 2. In question F, we have root 15 over root 75. Now, root 15 can be written as root 3 times root 5, and root 75 can be written as root 25 times root 3. Now, the root 3's cancel top and bottom. So we have the square root of 5 over the square root of 25, which is equal to root 5 over 5, and that's our answer. In question G, we're given 1 over 2 plus the square root of 2. Now, to get rid of the root on the bottom, we need to multiply top and bottom by 2 minus root 2. So on the top, we have 1 times 2 minus root 2, and on the bottom, 2 plus root 2 times 2 minus root 2. So on the top, we have 2 minus root 2, and on the bottom, we have the difference of 2 squares. So that's 2 squared minus root 2 squared, which is 2 minus root 2 on the top, and on the bottom we have 4 minus 2, so it's 2 minus root 2 over 2, and that's our answer. In question H, we have 12 over 3 minus root 5, so we multiply top and bottom by 3 plus root 5. So on the top we have 12 into 3 plus root 5, and on the bottom we have 3 squared minus root 5 squared. Well, on the top it's still 12 into 3 plus root 5, and on the bottom we have 9 minus 5, which means on the bottom we have 4. Now, the 12 and the 4 cancel to give 3 on the top, so we're left with 3 into 3 plus root 5, which is 9 plus 3 root 5.